Are you able to see? All right, so we are actually behind by one section. So we want to finish this one. Did you guys have any questions? I will extend the time for the homework. Do you have any questions on the homework? If you have any questions, I usually have the office house. I have never seen it. Oh, you can once, yeah. I've never seen it. So you can, I have a link, it is in Moodle, so you can use that one to connect if you have any other questions, okay? So it's 1 hour, 30 minutes from 12 to 1 every day, Monday to Friday. Okay, so let's do this. So section 6.1, I had introduced it, and it is about the greatest common factor, the greatest common factor. And it said the greatest common factor of 2 or more expressions is the largest expression, that is a factor of all the expressions. The largest expression. So how do we do this? So how to do it? So first step is you find the GCF, which is the greatest common factor of 2 expressions. So how do we find the greatest common factor of the 2 expressions? So the first step is, so step number 1, factor each coefficient into primes. 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 Number 2, list all factors. List all factors. You need to list all the factors. Number 3, bring down the common factors that all expressions share. Bring down all the factors, the common factors that all the expressions share. Number 4, multiply the factors. Multiply the factors. So those are the few steps that you need to follow when you want to get the greatest common factor. Now, let's look at an example here. Find the GCF of 45 a square b cubed and 18 a raised to 4 b. 18 a raised to 4 b. So how can we find the GCF of those? So what you do is you put them, start by getting factor each coefficient into primes. So what I do is I put it like this: 45 a square b cubed, and then I draw a line here, and then I put here 18 a raised to 4 b. And then now I look for the primes of each one of them. So if you still remember, when you're getting the primes of, let's say, 45, you get the factors which are what? Multiplying to get what? 45, right? And the smallest of all was what? Is what here? 1. You can start from 1, right? So let's say 1 is 45, right? The next one is what? 3, right? 3. So when you divide 45 by 3, what do you get? 15. The next one again, the smallest that divides 15 is what? 3, right? And then you get what? 5. So 5 by 3 is 15. By 3 is what? 45. And then for the 18, we have what? The smallest again is 2. Then you get what? 9. And then what? 3 and 3 and 3, right? So 3 by 3 is 9, by 2 is 18. So looking at these, so the first one is now factor each coefficient into primes. So these are the primes. These are primes. Is 1 a prime number? So 1 is not a prime number, right? 2 is a what? A prime number. 3 is a what? So we factor them into primes. Now, we now start by this from the smallest. Now, looking at 18 and 45, which is the smallest between the two of them? I still have 2 here. So it is 2, right? Do we have 2 in 45? No. So we leave this one blank. The next one is what? 3. Do we have 3 here? Yes. The next one is what? 3 again, right? In each one of them. So these are 3 and 3. What is remaining in 45 is what? Is what? 5. So this is 5. Do we have 5 in 18? No. So we leave it there. And then, so these are what? 3, 3, and 5 is what? 45. 2, 3, 3 is what? 18. Now we factor the others. So we still remember what we did in the last class, right? So what did we do? So a raised to 2 is similar to a by what? A. So we have our a here, and then we also have our a. Do we have a in 18? We have 4 of them, right? So a, and what? And A. So there are 4 A's in 18. There are 2 A's in what? In 45. And then let's come to the next one, which is what? B. How many B's are in 18? In 45, sorry. 3. So we have B, 2, 3. And then the one in 45 is what? B. So we have done the first step and the second step. So we have listed all the factors. So the first one and the second. Now we bring down the common factor in each one of them. So is 2 common here? No. Is 3 common? Yes. So we bring down 3. Is 3 common here? Yes. Is 5 common? No. Is A common? Yes. Is A common here? Yes. This A is not common. This one is not common. Our B here is what? Then we do what? We multiply the factors. So 3 by 3 by A by A by what? By B. So what do we get? 9A square B. And this one is our G, C, F. So this is our greatest common factor. Are we together? That is called greatest common factor. Any question? Any question up to that? Okay. Now, if we had given 3 of them, find GCF of 12 Z cube, 45 Z square, and 18 Z raised to 5. If we have the 3 of them. So we do this. So can you try that? So you put them just now. So this is 12 this cube. This is 2, and then this is square. This is 5. What is our greatest common factor? So the smallest here is what? This one. So if I start by looking at the smallest here. So because the other one, so that's it, not the other one. Then what is the greatest that can divide 18, 45, 10, 12? Very, right? So you can just see it without using the steps. So for you not to make any error, then you need to write them in that column form. So we have our 12, you get the primes. which is 2, 4, 6, and then 2, 4, 3. We have our 45, which is 3, 15, and then 3, 5. And then we have our 18, which is what? 2, 9, 3, and what? And 3. So we start from the smallest in each one of them, which is 2. 2 is found in 12 and what? And 8. Then 3 is found in all of it, right? So 3, 3, 3. What remains? So 2. Oh, we still have another 2. Sorry. We still have another 2 here. For what? For 12. Still have another 2 there for 12. So 3, 3, 3. So we don't have another 2 here. Then we also have, we don't have another 3 for 12. This is already 12. We have another 3 for 18 and 45. Okay. Do we still have another 3? So we already have 9 here. We already have 18 here. So what remains here is what? 5, right? 5. So we don't have another 5. So what remains are the Z now. So we have 3 of them here. 1, 2, 3. We have 2 here. And then we have 5 of them here. So we bring down the what? The common. The common one is 3. Do you have another common one? And then Z and what? Z. So our greatest common factor is equals to 3Z squared. 3Z squared. Any question after that? Any question? Okay. Now, if we have an equation, and we are told to factor an expression, an equation has the equal sign. If we have an expression q squared minus 2q plus 6q minus 12 here. If we are told to factor that means we want to bring out something which is dividing each one of them. Or we can group it. Like we group this one. And we also group this. Okay. So we can group this. Because here they have a common factor here in this one. Okay, sorry. We can group this because they have a common factor here. So in this case, we can group this one. And now, since this sign here is positive, so it doesn't change this sign here, right? So we can group this one like this. Are we together? You see this sign here. If this one was negative, before we put the brackets, then if this was positive, then we should put here what? Negative. Are we together? Because we are putting the brackets. But now, since this one is plus, then it doesn't affect anything there. Okay. If it was negative here, let's say this one was negative and this one was before the bracket and this one was plus, then once we put the bracket, then we need to put here minus, and then this minus here will remain outside. Are we together? Okay, so when we group this now, Then we need to factor out the greatest common factor in the first one. So what is dividing all of it? What is the highest value or factor that can divide q square and right? So we can factor out this q here. And what remains inside is what? Q, right? And then what remains here is what? Minus what? Minus 2. Because when we open this bracket, then it will be q square minus what? 2q. Plus, what is common here is what? 6, right? 6. We factor out 6. And then what remains here is q. And then minus what? Minus 2. Minus 2. Are we together? Now, looking at this, the whole of it, looking at the whole of it, what is common? Q minus 2. Now, when we factor out q minus 2, what remains? Q plus what? Plus 6. Q plus 6. Are we together? Exactly. Okay, let's do another example on the set. Now, if we have x squared minus 6x plus 3x minus 18, factor that by grouping. Factor by grouping. Now, again, we do the same thing. We group the ones which are having the common factor. And we can see here the common factor is x there. The common factor here is what? Now, before you put the bracket, then you need to look at the sign inside here. It is still positive and negative. So you can put it like that. And then now you factor out the common factor in each one of them. Now, in the first one, the greatest common factor there is x. So x. What remains is what? X minus 6. Plus, the greatest common factor here is 3. What remains is x minus 6. Okay, in each of these, what is the greatest common factor? X minus 6. What remains is what? X plus 3. So when you open this, when you want to expand now this one, then you do the same way. So you multiply this by this, minus this by this one. Like you need to do like this. So x plus 3 minus 6, x plus 1. And it will still bring you to this. Okay? So it will still bring you to that. So this is our factor by what? By grouping. Okay, now we have another one here. Yes, this one. U square minus 9u minus 2u plus 18. Factor this by grouping. Factor by group. So we have minus sign. So we have So when we group this, you still remain the same, but now this one is minus. So before we put the bracket, then we put that one minus. So when we group this, then it will be u square minus 9u brackets or parentheses minus now 2u minus what? Minus 18. Minus 18. Okay, and now we do what? We factor out the greatest common. So our greatest common factor in the first one here is what? U. And then u minus 9. Minus our greatest common factor here is what? 2. U minus 9. What is our greatest common factor in each one of them? U minus 9. What remains is what? Minus 2. U minus 2. Anyway. Yeah, because when you open this bracket, so it will be minus 2u, because since there is a minus a 1 here, which is imaginary, right? So minus 1, 2u. So when you open this bracket, then you multiply by each one of them. So it will be minus 2u. Again, this one will change to plus, right? So you need to change this, because since you are enclosing this one, so because there is a minus outside, then it should, and there was a plus here. So when you open the brackets, then it should come back to this. Okay. So do not confuse, because most if you don't consider that, then you might not get the grouping, because these examples will lead us to quadratic equations. Whereby now we need to put the equal sign there and then get the values of u. So to get the values of u, then it will now be u minus 9 equals to 0, or u minus 2 equals to 0. So the values of u there will be u equals to 9 or u equals to 2. We will come to that in the next section. Okay. Same example, another example here. Factor ab minus 2b minus a plus 2. Factor that. Factor that. So we do the same thing by grouping. So once we group this, so a plus ab, so ab minus 2b. Since this one is minus, a minus what? 2. Then we factor out the greatest common factor here, which is what? B. A minus 2. Minus. What is the greatest common factor here? What is the greatest common factor? 1. 1, yes. So 1, a minus 2. So what is common, greatest common factor here again? A minus 2. What remains is a minus 1. Any questions? Now, if we are given These ones were 4 of them. This you're able to group them because they are 4. So you can be able to group this and this one. Now, if there are 3, if there are 3 of them, and you're told to factor, like for example, minus 14p raised to 5 minus 44p raised to 4, and you're told to factor that. So again, using the previous part, then we need to get a greatest, each one of them. Each one, and then we factor it outside. Factor it outside. So looking at this, before you even do anything, what is our greatest common factor there? What is our greatest common factor?
-2p4.
No. Before we even calculate it, what is our greatest common factor? Negative, right? You can factor out negative. So you can factor out negative. Then you do the same way like what we did. We can do it the same way like what we did. So you take 14p raised to 5 and 44p raised to 4. Then we look for the greatest common factor. So we have 2 and 2 in each one of them. So 14 is what? 2 for what? 7. 44 is what? 2 for what? 22. 2 for 11. So we still have 2 for 44. And then we have 7 for that one. And then we have 11 for this. And then we have our 5 p's there. 1, 2, 3, 4, 5. And our 4 p's here. So what is our greatest common factor? 2 here, right? And then how many p's? 4. 4 p's. So 2p raised to 4. Now, once we factor out 2 here, so we can cross that. And we can cross, since that one has been factored out, we cross that one. Since these ones have been factored out, 4 of them, we cross that. Yeah, are you seeing that? So what remains in 14? It is what? 7p, right? What remains in 44? 22. What remains is 22. So therefore, since our first common factor was negative, and then our second common factor is what? 2p raised to what? 4. Now, what remains in 14 is what? 7 what? What remains in 22 in 44 is what? Plus what? 22. Plus 22. How it be that? Yes, plus 22. Now, when we open these brackets, what do you get? You get negative 14p raised to 5. And then negative what? 44p. P raised to 4.
What's it called when you write it out all the way like that? Like, if I was asked a question, what would I have to ask to write up the remaining? Would you typically just write the greatest common factor, or would you also write the remaining?
You can factor it like this.
Like what's the form?
Yeah, like if the question was asked, but if you like
all the factor by grouping. So in this case, you're trying to get something which is dividing all of them. Like in this case, 2p raised to 4 is dividing the greatest common. We used to call it greatest common divisor. I don't know why they say greatest common factor. So you get something which is dividing the greatest of all, which is dividing 44 p raised to 4 and 14 p raised to 5. And what remains is now is actually that's remainder. You get a remainder, which is 7 and 22 is what remains after dividing. So if you did this one, you still remember this. If you have let's say here is 44 p raised to 4, and then you divide by 2 p raised to 4, right? So what is the greatest number that when you multiply this one, you get 44 p raised to 4 or less? So what now? You still remember this long group? So it is what? 22, right? So you get what? 22 what? 22, right? So this by this one is what? Or what I could have done is, let's put that. What is the greatest common? What is the greatest number which when you multiply by 22, you get 44 p raised to 4 or less? So you can get 2 p raised to what? So 2 p raised to 4 is what? 44 p raised to 4. And what you get is the remainder, which is 0. But now if we have the one by something like that can have a remainder. Let's say 14 here. 5 here. 2, 3. Okay. You have something like that. So what is the greatest number that multiply this one, you get 14 p raised to 5 or less? What? 7, right? 7 p raised to 4, right? What do you get? You get 14 p raised to 4.
Would that be 4 or just be p? 7 and p 6.
Okay, let me not confuse you about here. Because I'm trying to do something which is
I think we're a question mark.
would further confuse you. So basically, what you're doing here, you're trying to get a number which is divided, which is the common, the greatest common number, which is dividing each one of them, and then you factor it out. That would be now the greatest common factor.
On a test though, like so if you had that question on the test, 14 p to the 5th minus 44 p to the 4th, how would it be worded so that we know what to write? That
So
is-
what I will tell you is factor minus 14 p raised to 5 minus 44 p.
it's just that.
Yes, yes. So the question will be factor. So another question can be which we are going to look at in the next section is so the next question will be so minus 14 p raised to 5 minus 24 p equals to 0. So when you go to solve, then this one you equate to 0. Okay? This one is less important. So when you equate this one to 0, so it will be equals to 0. So minus 2p raised to 4 is equals to 0, or 7p plus 22 is equals to 0. So you get the values of p. So we'll look into that. But in this section, it does be faster. So it's a continuation of the next section. So in your exam, you can just be told to solve the equation. So to solve this, you follow this, the following. So this is a step in getting to the solution. Okay. Any question? All right. So. Now, if we have another one here, like 12x cubed plus 42xy raised to 6 plus 42xy. Factor. So the question is factor. Factor. So without even using the long way of getting it, what is the greatest common factor in terms of x and y there, which you can bring it up? So when we look at the first one for x raised to 3, we have here x1, right? We have here x raised to 1. So the greatest common there is what? X. So you bring out x. Okay. So in this case, what remains here is what? What remains here is what? X squared. What remains here is what? There is no x, right? What remains here is what? There is no x. Okay. Now, another common thing here, do you have y here? We don't have y. Do we have y here? Yes, we don't have. So the y will not be greatest common factor. So it will not be. Now, we have 12 here, we have 42 here, we have 42 here. What is the highest number that can divide 12, 42, and 42? 6. So if you divide by 6, you get 2 in 12, right? Divide by 6 in 42, you get what? 7. And the other one is 7. So 6 here. So what remains inside here is what? 2, right? 2. This one will be what? 7 what? X has already been factored out. 7y raised to 6. The next one is 7y. And you have factorized that. You have factorized that completely. Any question? Any question? Now, this one will bring us to section 6.2. This will bring us to section 6.2. And if we have an example, if we have d squared minus 18d plus 56, this is actually the quadratic expression. Quadratic, it's leading us to a quadratic expression. Now, if we have quadratic is where the highest power of the highest power of this is 2. So the highest power is 2. So once the highest power is 2, that becomes the quadratic expression. If there was an equal sign here, it becomes quadratic equation. Becomes quadratic equation. Now, how should we solve this quadratic expression? How should we solve this quadratic expression? So here, there is what we call the AC method. The AC method. The AC method. This is whereby we, for example, we have a common quadratic method here, which is ax squared plus bx plus c. Ax squared plus bx plus c. So here our a is this, the coefficient of x squared. Our b is the coefficient of x, and our c is the constant. So the AC method is whereby we look for a number in which the product is AC and the sum is B. The product is AC and the sum is B. So in this, it is similar to this one. Now this is d squared, which is similar to x. We can put anything. We can put y, x, z, something like that. So as long as it is in this form, then when we want to factor this one, then we look for a number in which the product, in this case, our a here is what? Our b is equals to negative what? 18. And our c is equals to 56. We look for a number in which the product AC. We look for two numbers in which the product is AC. And our AC is what? 56. And the sum of the two numbers is equals to B, which is equals to minus 18. So what are the two numbers in which the product is 56 and the sum is negative 18? So again, we look for the factor for 56. So what are those two numbers? Four and what? 14, right? So 4 and 14. So 4 by 14 is what? 51. 56, right? But now the sum here is minus 18. So that means the two of them should be what? Minus, so that we get what? Minus 18, okay? Minus 18. Okay, we can meet on Friday and then we finish on the other section.